Hey, welcome to 6502 Emulator in Python Part 2 with Tokyo EdTech. That is me. In today's video, we are going to continue what we were doing in the last video, and we're going to do some code improvements to make it so that it's a lot easier to add commands and to make changes and to do certain things. And then we're going to try and implement some commands in the 6502 language, INX, INY, DX, DEY, tax, TXA, TAY, TYA, and I'll explain those later. So let's get started. Here is what we have so far. If you haven't seen the first video, please go watch it. I will put a link down below so you can start with this exact code, and I'm going to go ahead and run it. And what we have in the output is kind of a trace of what was going on, but basically I had a few commands entered here. Let's go ahead and take a look at that. We had LDA, LDX, LDY, STA, STX, STY. Basically, we loaded those. We've loaded those values into those registers. And again, I'm assuming that you watched the previous video. So here's A, X, Y, and then we store them into certain memory locations. So what I want to do here is I want to improve the code. We're seeing some repeated code, and repeated code is the bane of every programmer. So you can see here where we're executing the code, we're going to have, how many if statements. I forget how many commands there are actually in the 6502 language, but here they all are. So 4 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 4 times 14, 40, 56. So 56 different commands. Then there's addressing modes and things we have to deal with. It would become a very, very large problem. But with some simple programming, we can go ahead and get around that. So what I'm going to do is I'm going to go into my initialization method here, and I'm going to do self.commands equals, and I'm going to make a dictionary. Okay, and so what I'm going to do is the key is going to be the opcode. So for example, let's do LDA. So that's 0xA9. So 0xA9. And then the value is also going to be a dictionary. And I'm kind of torn here. I could do a list. I could do a dictionary. I'm going to do a dictionary. And the first one is F. And the second one is going to be, mode. Okay, I could do M, but F is going to be for function. Or I could call it FX. I don't know, what do you want to do? Function. And let's make it F because it'll make it shorter. It's going to get too long. And we're going to do, let's do M for mode. Let's keep it consistent here. Okay, and I'm just going to put a 0 here for now. And let's do LDA. And I'm going to put here, self and mode. And the problem is that the mode is, I see. Yeah, we'll be fine. LDA self mode. Actually, no, sorry. It's going to be self.lda and mode. Sorry. Let's try that. Let's see what happens if this even still runs. I got code here. So LDA mode. This mode is not defined. Okay, let's get rid of that. So we don't need that. Go ahead and compile that. Okay, it's still compiling. And hopefully this is going to do what I want it to do. So here's what I'm going to do is instead of this section of code, I'm going to change it. So what I'm going to do, I'm going to say if command in commands. So if 0xA9 is in this set of commands, what I'm going to do is I'm going to pull out the function, and I'm going to say f equals commands. It's going to be command, and then I want the function. Okay, so what that means is if the command, which is the opcode, is in this set of commands, I'm going to pull out the function, which in this case is self.lda. And then so since self.lda now is F, I should be able to call it like that. Now this is a bit of a supposition. I didn't test this ahead of time, but we'll see what happens. Got a 1, so commands is not defined. Of course, that should be self.commands. I keep doing that. Let's try that again. Code 1, self.commands. Alrighty. Exit was 0. And you see here, we still got the exact same result as we got last time. So this tells me that what I just did worked. Okay. So what I just did worked, which is pretty freaking awesome. Okay, so now the problem is I want to do the same thing for all of these commands. So notice so far nothing down here has changed. But the problem is that based on the mode, we haven't really talked in detail about the mode, but based on the mode that we're using, the program counter increment changes. Okay. So let me go ahead and go back to here and explain this real quick. So LDA. So what we've done so far is we have done the immediate mode only. So this is the opcode and this is the value. So you see here the length is 2. So because of that, we do self.pc plus equals 2. So anytime that the mode is immediate, we're going to have a length of 2. So if I go down here, I look for immediate, it's always going to be a length of 2. Okay, so 0 page, immediate, do I have any more immediates? There's implied. Immediate 2, 2, 2. Okay, so we can use this information to simplify this code. So based on the mode, we can get the counter for the PC. Okay, so what I'm going to do is I'm going to go ahead and create what we call this. So increments, we'll call it increments for the program counter equals. And again, I'm going to do another dictionary. And what we're going to do is we're going to have the mode. So for example, the first mode was immediate. And that was a 2. Now here's where it gets a little complicated. You may not have seen this before. The problem is that immediate, of course, is not defined. Now I could just put this in quotes and make it a string. And that would work. I could do this. I could do immediate. I could do self.immediate. And then up here, I could do self.immediate equals 0. Give it a value of 0, for example. But what I'm going to do is I'm going to use something called an enum. And if you're coming from another language, you might already know what this is. So in Python, to make an enum, it's going to look like this. First, I'm going to have to import some stuff. So I'm going to from enum, import enum, and I'm going to import auto. I don't have to do that, but I'm going to do it that way. I chose. And I'll explain this as we go along. So then I'm going to go ahead and do class mode. And it is a child class, I guess, of enum. And this is where I'm going to make my modes. So I'm going to do immediate equals an auto. And what that'll do is like this will be 0, the next one will be 2, 3, 4, 5, etc. So I think so far we've done immediate, and what was the other one we did? We did was absolute. Okay, so we'll do absolute equals auto. So then in our code, what we're going to do is we're going to write, this is mode. And notice the drop down shows me that I have absolute and immediate. And this one was immediate. And then, so then what we can do here equals self dot, what was it? Increments. And we're going to do the mode. self.increments mode. Now, where does the mode come from? So m equals self.commands. Command. And I think I did an M there. Now, again, I could combine these statements. Not a big deal. And then here, I'm going to do X. This will be important later. So I'm going to actually pass the mode to the function as well. We'll see what I do with that in a minute. So self PC plus equals self increments M. Actually, if I do it that way, I don't really need to do that. Interesting. Well, let's think about that. We'll leave it like this for now. I've got an error. No attribute. Not immediate. Yeah, like usually when I do one of these videos, equals self.immediate. It's not self. Sorry. Usually when I do one of these things, I practice it ahead of time. But this is, I'm actually just kind of live coding it. So you're going to see a lot of mistakes. Immediate is not defined. It's mode.immediate. Duh. Compile that. Okay, now, and again, we're still seeing the exact same output. So this is telling me that what I'm doing is working. So now that I have this, I can go ahead and do 0xa2. I can go ahead and do 0xa0, LDX and LY. So I'm going to put that here. And I'm going to go ahead and get rid of this code, so I won't need it anymore. So to add that particular command, I'm just going to go ahead and copy what I have here. So this is LDX, mode immediate. This is LDY. The hex code is A2. The hex code here is A0. So I'm going to save it and I'm going to test it. Okay, so even though I deleted those statements, I should still be able to get what I need here. So let's go ahead and try that. Let's run it. And we're seeing the exact same output. This is telling me that this approach is working, which is pretty cool. So let's go ahead and do the other three commands that we did last time. So we have STA, we have STX, and we have STY. Now these are a little bit different because the PC is 3. Okay. So I'm going to go ahead and just copy this again. Just to make it clear that's a separate section, put a little space there. And this is going to be STA, STX, and STY. And the opcodes are 8D, 8E, 8C. 8D, 8D, 8C, and 8E, DCE, DEC, excuse me. DEC, E, and C. So I'm going to go ahead and just delete these. And here I also have to add mode.absolute. And that is 3 on the PC counter because, let's go back here. LDA. Well, the word is, but absolute, okay, is a length of 3. So we need to add 3. So I'm going to go ahead and, so I'm going to test it and hopefully we'll get the same result. Okay. Okay, so well, we almost got the same result. Okay, it shouldn't be mode immediate. It should be mode absolute. And absolute. Let's try that again. And here we go. We have the exact same results. 68, 69, 70, 68, 69, and 70. So hopefully you can see what I did there. Okay. So I took that entire section of if statements and replaced it with an entirely different section of code. So basically now I can define all of my commands here. I can define all of the increments for each command here based on the mode. And then down here, I just do all of this. Now there's still a problem, which I'll explain in a minute, but as you can see, this is working for what we have already coded, which was basically LDA, LDX, LDY, all immediate, and store A, store X, store Y, all absolute. So storing it into a particular memory location. Now the problem is, if I go back to the document here, is that LDA has a number of modes. Okay, so it has immediate, zero page X, etc. It has immediate. So we're going to do immediate. We'll work on immediate and absolute today. So LDX also has immediate and several others. LDY has immediate and several others. So what we're going to do is we're going to work on immediate and absolute. Because once we get that done, updating the code is really easy. So we're just kind of trying to get the basic code structure down. So for this, what I'm going to do is I'm going to go ahead and get rid of, or actually I should say get rid of. I'm going to create a new method. Okay, so def. I'm going to call this get location by mode. And it's going to be self, and it is going to be mode. So how this one's going to work. So if we look here, actually look down here. So notice the location that we did here. This was only for immediate. Yeah, immediate. It was the program counter +1. So down here, so it was, if this was the program counter was here, we're going to load this memory location. So here's the program counter +1. So anytime it's immediate, it's always program counter +1. Program counter +1. So let's go ahead and code that. So I'm going to say location equals self.pc plus 1. I should put a little space like that. So what I got to do here is if mode equals mode dot immediate, the location is always going to be self.pc.1. C equals 0. Let's just set default, and then we're going to return LOC. So I'm going to go ahead and test this. You notice I'm not going to add anything else until I've tested this particular aspect. So then up here, so we've already created the function, we've passed the mode to it. So in LDA self mode, instead of here, so find the location based on the mode. So I'm going to say LOC equals get location by mode. And then here I'm going to put LOC. Again, I could combine this, but I'm trying to keep it separate so that it's easy for you to read and for you to understand. So I'm going to go ahead and just copy this. I should test it, but I'm pretty confident this is going to work. So for LDA, LDX, LDY. And I missed the first. Well, maybe I don't need that after, but let's go ahead and put it there. Just so it's clear what's going on here. All right, let's run it, and we should get the same result. Well, we got an error. Get location. Jeez. This is why you always test it. So self get location by mode. So we're going to copy that. Alrighty, let's do this again. And we have the exact same results. This is going very, very well. So now we're basically setting a general function that will get the location no matter what, based on the mode. So once I've updated this part, STA, okay, so now in this case, we want to get the location. And so we're going to do if mode, so do elif mode equals mode.absolute. And I'm just going to go ahead and copy this because I'm kind of lazy. Copy. So again, same thing. Anytime the mode is absolute, the location is oops, actually it is, no, sorry. This is correct. It is the value of is the value in, so it is basically, you know, PC plus 1, this is the least significant byte for whatever this value is. Most significant byte, whatever this value is, and as we saw before, times 256 plus, so the most significant byte times 256 plus the least significant bytes. So we're going to use that exact same formula here to get the location. So now what I can do is copy this. Equals. The exact same thing here. It's a little different. So let's go ahead and do location. It's not loading, sorry. So I'm going to go ahead and be able to replace this, okay, with that. Let me say update memory. Update memory. All right, I'm just going to go ahead and I know I'm breaking the rule again, but call it overconfidence, call it hubris, call it what you will. So let's go ahead and see if we got the same results. Okay, it ran and we are getting the same results. This is a wonderful, wonderful day. So what I was able to do here was that I was able to eliminate all those if else if statements, if, by using a dictionary with the opcode as the key, another dictionary as the value, and in this I'm storing the command that we're going to call and the mode of this particular opcode. Okay. So we have mode immediate and mode absolute. Okay. So we're using this as the increments, and then here this basically says if the command that we've got, the opcode, and now I maybe should have called opcode and opcodes, but that's okay. We'll call it commands for now. And so we pull out the function, we pull out the mode, we call the function and the mode, and then we increment the program counter based on the mode. Pretty cool. So then down here, instead of having to calculate each time instead of having to do like if the mode equals this, here's how we get the location. If the mode equals this, then how we get the location. We now just use this one function that will give us the location based on the mode, which again is pretty cool. Okay. So let's go back to our list of coding concepts we wanted to do today. And it says here, we want to add INX, INY, DEX, DEY, TAX, TXA, TAY, and TY. I chose these because these are very simple commands to implement. So INX means increment X, INY means increment Y, DEX means decrement X, which means subtract by 1. DEY means subtract 1 from Y, decrement Y. TAX transfers A to X. TXA transfers X to A, and by the same token, TAY transfers A to Y, and TYA transfers Y to A. So let's go ahead and code those, and that's how we'll wrap up this particular video. Now I'm going to go back to this particular page and take a look at the first one, INX. Okay. That was not, did I click the wrong thing? INX. Oh, there it is. Okay. So see here, it says these instructions are in implied mode. So they have a length of 1 byte. Okay. So this tells us that we have a new mode that we haven't done before. So I'm going to go ahead and do implied. I'm going to add the mode, implied. In my increments, I'm going to add mode.implied, and it is just 1 byte. So it's implied, it just does it by itself. Pretty easy peasy. And then what I'm going to do up here, what I'm going to do here is I'm going to add those commands. So I'm going to copy one of these. We'll do INX, we'll do INY. So I should just delete that. Oops. And these are going to be implied. So implied. Oops, implied. And we're going to do INX and INY. And let's get the opcodes for that. So INX is E8, INY is C8. So we got E8. C8. Alrighty. Now, let's see what else we got here. Let's just run this, make sure everything's still working. Okay. Okay, that's what I forgot. So we need to create the method. So I'm going to do INX. So def INX, it's going to be self and mode. Okay. Now in this particular case, it says find the location based on the mode. Okay. So the location of X is always X. So all we need to do for this is self.x plus equals 1. And I'm going to go ahead and do the same thing. For self INY. That's going to be self.y plus equals 1. Now I'll have to go down here and add a little bit of this code here. So let's go ahead and add those two commands. It's going to be EF, and then we're into 10. I can update this, remind me. 08E, I think it was 8C, was it? All right, go check. That thing is very easy. I should have this on a separate paper. E8 and C8. That was close. Not. E8 and C8. And this is INX. And this is INY. And then what I'll do down here is I will add another print statement. And I'll say, let's print out the values of A, X, and Y. Just do that. Okay. If we do that, we should see the same values twice and then subtraction on the X and Y, or addition on the X and Y. So let's run that. Okay. So, okay. So we can see actually now that X is now 70, Y is now that. Let's go ahead and put, let's just go ahead and just add that F quote, and this is going to be A colon, and okay, because we're going to end up doing this a lot. So F quotes X colon, boom. And I should make this a function later, maybe next time. F quotes Y, doop. Okay, now again, every time you see repeated code, that tells us we would like to do something with that. And we'll come back to that another time. Okay, let's run that. Okay, so we see that A is 68. It used to be 68. Remember, it was 68, 69, 70. Then we stored that into here. And then here we added 1. So we can see that INX is working. We can see that INY is working. So then now it's really easy just to add DEX, DEY. Okay, so we got DEX and DEY. So let's go ahead and do those. For first, I'm going to do the functions. So do I need to put these in here? INY. And so all we got to do is just copy those. So you see now, once we've done this, it gets really easy to start adding commands. DEX and DEY. And in this case, it's going to be X minus 1, and it's going to be Y minus 1. And then we also have the other ones. Let's go ahead and just finish this out. My throat's getting a little dry. You can probably hear it. TAX, TXA, TAY, TYA. Okay. So we're going to go ahead and do... oops. Go back to the coding. Sorry. We're going to do TAX. So DF, AX, self, comma, mode. And self... So in this particular case, TAX means self X equals self.A. So we're transferring the value of A, the accumulator, to X. So I'm just going to go ahead and copy that 4 times. I'll copy it twice. And we're going to do TXA. And so that transfers X to A. And this I will copy. And we can do the same thing with Y. TAY, TYA. And just put that as Y. Now I'm not gonna bother testing this for now because it's about time to end this video. But I'm reasonably confident this is going to work. Again, I need to go ahead and update this as well. So I'm going to copy one of these. There's 4 commands. But these are all implied modes, so that's going to help. Two, 3, 4. And I'm going to go ahead and open that up. Actually, maybe it'd be easier if I just did that. And kept those on the screen. Yeah, why didn't I think of that before? So we want to do TAX, which is AA. We want to do TXA. So self.TAX, TXA, TAY, and TYA. So 0AA, TXA is 8A, and TAY is A8, and TAY, right? TAY, A8, TY is 9.8, and that is 9.8. So we were able to add those commands pretty quickly and easily, I think, compared to how it was earlier in the video. So I'm going to run this to make sure everything's still working. No attribute TXA. Again, let's see if I did this wrong. Yeah, I forgot TXA. You guys probably noticed that, didn't you? TXA, TAY, and TYA. All right, let's try that again. And again, I should test this, but again, I'm kind of running out of steam here. I do apologize. But I'm going to be confident, and hopefully those will work. We'll see later. We'll probably have to add some more testing code. I really want to redo the testing code, or the way that I add the testing code, because it's getting a little bit cumbersome. But yeah, we can deal with that in the next video. So yeah, that's pretty much it. So there was actually a lot of coding stuff in there. First is this enum, and it's basically, it assigns a numerical value to this. So this would probably be 0, 1, 2. We could have done that ourselves, but I prefer to do it automatedly in an automatic way. Is that a word? And then now that we've got this set up and working, we can add any command we want just by doing this. So it's the opcode, the method, and the mode. Now, we've only done implied, absolute, and immediate so far, but there's quite a lot you can do with that. We have our increments. This is also a dictionary. So immediate is +2 on the program counter. Absolute is +3 on the program counter. Implied is +1. So we fetch our command from the current location of the program counter when we tick, and we're showing that you can scroll up and see what it's doing, but yeah, maybe we don't need that. Let's get rid of that for now. That was just for debugging. And then we check if the command is in the commands. Actually, I should probably put else print f quotes. What's this? Say dent command. That'll be an opcode. Not implemented. Let's just go ahead. I do want to test that one. I'm going to go ahead and just down here and just change this to like AF. Run that. See command 175 not implemented. Okay, and then nothing worked there. Command Z. Okay, let's try it again. And we still see what we were hoping to see. Now it says command 0 not implemented. That's okay. That is what we wanted to happen. That's to be expected. Anything else I want to change here before I close it? You know what? I think that's it. I think you guys have sat through enough. Oh yeah. Also, based on the mode, it tells us the location of where the data is coming from. So if it's immediate, it's coming from the next byte after the opcode. If it's absolute, it's coming from the values stored in the next 2 bytes. Least significant bit first, or byte first, most significant byte second. We calculate the location from that. And that's the only 2 that we've done so far. You notice there's no location for implied because we're not actually getting any data. It's implied. So it's the X register, the A register, or the Y register. So we don't have to go to the memory. We're just using the registers. And yeah, other than that, I think it's pretty clear. So yeah, thanks for watching, and keep on coding. Hopefully I'll come back to this as soon as I can. Take care.